Circles on the ACT. Question 1. A central angle intercepts an arc of 110 degrees. Find the central angle. Step 1, a central angle has its vertex at the center of the circle and it equals the arc that it cuts off. So the central angle here is just 110 degrees. The trap is like cutting it in half or just not knowing what the definition is and kind of freaking out. But the correct answer here is A, which is the correct answer to the first question in the study guides at app.classictestprep.com. Question 2, a circle has radius 10 and a sector has a central angle of 72 degrees. Find the sector area. So step 2, a sector is a fraction of the whole circle, and that fraction is 72 over 360 because there are 360 degrees in a circle, and this sector has 72 degree angle creating it. So that is actually 1/5, and the full area of the circle, so the entire area of the circle is pi r squared. The radius is 10, so it's pi times 10 squared, which is 100 pi, and we need 1/5 of that in order to get the area of the sector. So that's 20 pi, which is answer choice C. Question 3, an inscribed angle intercepts an arc of 130 degrees. Find the inscribed angle. So step 3, an inscribed angle is different than a central angle. An inscribed angle is out on the vertex of the circle on the other side of the arc that it intercepts. And so the correct answer is the measure of the arc divided by 2. So the answer here is 130 divided by 2, which is 65, and that's answer choice D. A line is tangent to a circle at point T. From an external point P, the distance PT is 12. And OP from the center to P is 13. Find the radius. So the radius drawn to the point of tangency meets the tangent at a right angle. So triangle OTP is a right triangle. And by the Pythagorean theorem, we can find that the radius squared plus 12 squared equals 13 squared. So the radius squared is equal to 169 minus 144, which is 25. And now we have to take the square root of 25, which is 5. The radius is 5, and that's answer choice B.